Okay, hi, hello everyone. So today's video is about solving a geometry question. So let's dive into it. Okay, so today's question is asking, okay, what is the blue area inside this region? All right, such that you are given that ABC is a quadrant. Okay, the length of AE is 4 cm. Okay, E to C is 8 cm. Okay, and you're also given that the angle, okay, BAD is 60 degrees. So what is the shaded area? Now, this is how I solve, okay, this question. I bring this diagram over to this slide. And, okay, same thing. Now, first of all, we can establish that since ABC is actually a quadrant, okay, and you're given that AE to EC, okay, is 4 cm and 8 cm respectively. Thus, AC itself is the radius of the quadrant. Thus, you also can say that the length A and B is 12 cm. Okay, because this is the radius as well. Now, the next step is I'm going to actually draw in a line. Okay, A joining to another point, call it D. Okay, I call it D. Okay, such that, okay, in this case, okay, BAD, remember just now we actually talked about, we are given that BAD is 60 degrees. Okay, so I actually mark it in 60 degrees. And since ABC, quadrant ABC, okay, is a quadrant itself, so angle BAC is 90 degrees. Thus, angle DAC is 30 degrees. Okay, so simple. Okay, so far. Okay, now I'm going to draw a line that will intercept AC perpendicularly. So in this case, I'll mark another point, F, okay, in which DF is perpendicular to AC. All right. Now, to find now my goal at this point is to find what's the area of EC and D. Okay, to find EC and D. Okay, simply I can just use, if you notice over here, there's a sector A, D, and C. I can just subtract it with the triangle A, E, and D. Okay, if I subtract the sector with the triangle, I get this area E, C, and D. Okay, this region here. Thus, if you remember, okay, the radius of the quadrant is 12 cm. Now, since A is the center of the quadrant, AD is 12 cm. Okay. Now, the area of the sector ACD, okay, very simple. I can just take it as pi over 12 multiplied by 12 squared. Okay. So this is actually based on the area of a sector. All right. So if you look carefully, okay, this is the sector ACD, ACD, okay, bounded by 30 degrees. So this is how I get 12 pi cm squared. Okay, very straightforward. Now DF, okay, the length DF. Okay, I can just very quickly apply, okay, basic sine ratio. Okay, DF is basically 12. Okay, because 12 is the hypotenuse. So 12 multiply of sine theta, which is 30 degrees. So in this case, okay, sine 30 is half, 12 of half is 6. So DF, therefore, is 6 cm. Okay, now the next step, okay, I'm going to attempt to find area of triangle ADE. So ADE, okay, the triangle ADE, okay, very simple, is half of the base. The base is 4 cm with respect to the perpendicular height DF. So DF, since we got it as 6, half of 4 of 6, we get 12, okay, cm squared. So thus, okay, the area of the region CDE, okay, C to D to E, okay, C, D, and E will simply be, okay, 12 pi, okay, minus 12, okay. I just use sector ACD minus triangle ADE. So 12 pi minus 12, okay, I can rewrite it as 12 of pi minus 1. okay, cm square. Now I have the region of area CDE. Now, very simple and straightforward. Why? Because I just have to find what is the area of this triangle. Thus, I can use the area of the quadrant to subtract away the area of the triangle ABE, as well as the area of region, okay, the area of region CDE. Okay, I hope you can see what I mean. So I just have to subtract these two unshaded region to get the shaded region. Okay, so this one I just add a checkpoint at this point. So area of triangle ABE, okay, is very simple, which is half of base, which is 4, and the height is 12, which gives us 24 cm square. Okay, check at this point. Now, the area of quadrant ABC can simply be found by taking pi out of 4, a quarter of the circle, of the radius 12, so 12 square, which gives us 36 pi cm square. Now, at this point, okay, these 3 checkpoints, what I can do is I just use the area of quadrant ABC, okay, minus the area of triangle ABE minus the area of the region CDE. Thus, that will give me the area of the region BDE, okay, which is the shaded region. Okay, so now I just plunge in my values, 36 pi minus 24, okay, minus 12 pi minus 12. All right, so thus I will get, okay, by simplifying the terms, I get 24 pi minus 12, okay? And nevertheless, the answer to this problem will be equals to 12 of 2 pi minus 1 cm square. Okay, and that is the answer for this problem. Okay, thank you very much. Okay, and hang on. Yeah, so thank you very much for watching and see you all again. Okay, good night. Bye.